Today's topic is division algorithm for polynomials. Okay, so we are familiar to two parts of this topic, division algorithm and polynomials. Now, when we talk about polynomials, you already know polynomial is an expression that consists of variables and coefficients with non-negative integers as power of the variables. Okay, now on depending upon the power of the variables or the degree of the polynomial can be of various types, right? Now, as we talk about the division algorithm part of our topic, the word which bounces in our mind as we hear the word division algorithm is definitely Euclid's division algorithm, which you studied in chapter 1. Right? Now, what was the division algorithm, Euclid's division algorithm, children? The mathematical statement is A is equal to BQ plus R, where you know what these stand for, right? So, if we were to divide 17 by 2, we could have written it like this. Okay. So, where 17 is the dividend. Okay. 2 is the divisor, 8 is the quotient and 1 is the remainder. So, we can write it like this when we divide 17 by 2. Okay. Now, similarly, when we apply the division algorithm on our polynomials, okay, when we apply this division algorithm on our polynomials, it simply becomes division algorithm for polynomials, and that is what we are going to study today. So, if we are to write this division algorithm for polynomials mathematically, how we are going to write it? We say, when a polynomial px is divided by any other polynomial gx, then px is equal to gx dot qx plus rx. Okay, we all know px is representation for a polynomial. Now, because we have used the term px, we are using gx, but it is again a polynomial. So, when we are dividing our polynomial px by gx, we get a quotient. Okay, for q, we can easily understand that this is the quotient and this is the remainder. So, we have written it in the same way as we had the Euclid's division algorithm. Okay. Now, as we used to state the restricted values of r, we used to say that this r is either equal to or greater than 0, or it should be less than b. Okay, here we used to talk about this, the remainder. Now, what is the remainder with us? The remainder with us over here is Rx, right? So, here we say either Rx is equal to 0, okay, for this, Rx is either equal to 0 or the degree. Here we talk, in polynomials, we talk about the degree of Rx and not the numerical value of Rx. We say the degree of Rx should be less than the degree of Gx. This is something very important you need to check when you divide a polynomial px by any polynomial gx. Okay, so this is our division algorithm for polynomials. So here we have just stated the division algorithm. Let us now also verify that whether really the division algorithm is true for polynomials or not. Okay, so for this I have taken a polynomial px and a polynomial gx, and I have divided my polynomial px by the given polynomial gx. So when I divide the two, I get a qx quotient and a remainder. What? Rx. Okay. So if I have to verify my algorithm, what I have to prove is simply I have to prove that the LHS should come equal to the RHS. Now the LHS or the PX, it is an equation simply, so it cannot be solved further. Okay, so I am going to solve my RHS, right? So let me substitute the values from here. Gx was x cube minus 3x plus 1. My qx came out to be x square minus 1 and the remainder was plus 2. So I write the values here. I do the multiplication plus 2 and then I solve the like terms. Okay. So I get finally x to the power 5 minus 4x cube plus x square plus 3x plus 1. Now my purpose is to check that whether the resultant which I have got is this same as the left hand side px. So let us see. X cube minus 4x cube plus x square plus 3x plus 1. So all the terms as well as the signs are all same as px. So we can simply say that here my left hand side is equal to my right hand side. So we have verified that the division algorithm is also true for polynomials. Similarly, you can have more questions and you can verify on your own as well. Now, one more thing which I wanted to cover with this concept is the relationship between the degrees of px, gx and qx. Okay. Now, if you recall that in our previous classes you have studied that if we are doing multiplication, okay, and we have some exponential terms, for example 5 to the power 2 into 5 to the power 3, we simply write it as 5 to the power 2 plus 3. That means in multiplication, if bases are same, the powers are added. Okay. But also here addition is there. Multiplication is there, but addition is also there. But there is no difference in exponent for addition. Okay, like if you have 5 to the power 2 plus 5 to the power 1, the answer will have no relationship for the power or the degree. So we will not consider the addition part over here. We will only consider the multiplication part over here. So by following the same rule, here we can say that the degree of px is equal to the degree of qx plus the degree of gx. Okay. From the given question also you can see the degree of a gx was 3. The degree of a qx was 2. So simply 3 plus 2 becomes 5 and this is also the degree of our px. So here also we verify 5 is equal to 5. So this is another one important thing which you should know. Alright children. So similarly, as you practice more and more questions, you will be able to explore your own facts. So please solve more questions. All the best. Thank you.